All right, to finish 4-1, we have to go from polar back to rectangular. So we're going to use these three equations that we know to be true, and try and go from polar equations or polar coordinates to rectangular equations or rectangular coordinates. All right, so this guy here gives a rectangular equation for each of the following. So here r equals 2 cosine theta. We already saw that. Saw that guy. What did I do? Did I do the focus? Oh, cool. I can focus, but it's not that great anyway. So I struggled with this for a long time. I know that x is r cosine theta, but do I know that r is a 2? Like, no, that 2 is just a number. R is a very, like, so I want to just say that r equals x, and we're going to go, but that's not necessarily true here. I don't have anything to officially convert them. So in an effort to match, right, I need to match r cosine theta. I need an r on that side. If this said 2 times r times cosine theta, then I could take the r cosine theta and turn it into x, right? But it's not there. So if I multiply both sides of this equation by r, right? If I multiply both sides by r, I would end up with r squared equals 2r cosine theta, right? Now, r squared is x squared plus y squared, so we get x squared plus y squared. And r cosine theta is x. So then on the right side, I get 2x. And they want these rectangular equations, they want them to be all set equal to 0. So we subtract the 2x, and we get our final equation, x squared plus y squared minus 2x equals 0. And that is the equation that they're looking for. All right, so let's try this next guy here. R equals 2 sine of 2 theta. Well, the issue is that I don't have cosine of 2 theta or sine of 2 theta. So I go digging in my formula sheet, and the sine of 2 theta is, right, so sine of 2 theta is 2 cosine theta sine theta. So I'm going to replace that guy with this here. So I get r equals 2 times 2 cosine theta sine theta. And now I can multiply those guys out. So r equals 4 cosine theta times sine theta. Now, I need to introduce an r value, right? If I introduce an r, I can get r cosine here, but I'd have to introduce a second one here as well. So ultimately, what I need to multiply both sides of the equation is r squared. R squared times r is r to the third. And then I'm going to take one of these and sneak it in for cosine. So I get 4r cosine theta. And the other one in front of sine times r sine theta. And now the right-hand side is pretty nice, right? There's an x and there's a y. And it's going to be multiplied by 4. But the left-hand side, r to the third, gross. I don't like that. So what I can do here is I square root both sides, then r to by itself is the square root of x squared plus y squared, right? R is this guy. So then I can replace the r here. So I would have the square root of x squared plus y squared. All of that cubed is equal to 4. Instead of r cosine, I have an x. Instead of r sine, I have a y. And get it all equal to 0. This is stupid, I guess, but we have the square root of x squared plus y squared cubed minus 4xy is all equal to 0. Neato burrito. Okay, on to the next. We're going to convert from polar coordinate to rectangular coordinate. Yeah, this is cool, I think. All right. So My angle here is negative 45 degrees. Negative 45 degrees. So I know I'm going this way. And my distance is 6 root 2. My R value is 6 root 2. So I need to figure out what my X value is and what my Y value is. There's a lot of ways we could go about doing that. I know the hypotenuse is 6 root 2. So my X value would be this guy, my Y value would be this guy, right? But it also told me earlier, I know that X is equal to R cosine theta, right? So I should be able to replace that with 6 root 2 times the cosine of negative 45.